All right, let's dive right in. Today, we're looking at a really compelling idea that offers a new way of thinking about age-related diseases. It's called the vicious cycle theory. So let's start with a question you've probably asked yourself or seen in your own family. Why is it that the biggest health problems, heart disease, Alzheimer's, they don't just show up one day? It feels like they hit the accelerator, getting exponentially worse as we get older. And look, this isn't just a feeling. It is a brutal, measurable reality. Take a look at this chart showing the death rate from Alzheimer's. You see how it just kind of putters along for a while? And then, bam, it goes almost vertical. It's a classic exponential curve. And we see this exact same terrifying shape for so many of the diseases we associate with aging. Now, the easy answer here is just, well, that's just getting old for you. But the author of this paper, Alexey Belikov, says, hang on, that's not good enough. The real answer, he argues, isn't just the passage of time. It's the pattern. There's a powerful mechanism hiding in plain sight. That J-curve, that exponential explosion, that is our biggest clue. It's like a smoking gun. Because in biology, when you see that kind of runaway growth, it almost always points to one thing. And that thing is a positive feedback loop. It's a super simple but incredibly powerful concept. All it means is that A produces more B, and B then turns around and produces even more A. Each part of the system feeds the other, creating this self-reinforcing cycle that just spirals out of control. It's a runaway train. And you've definitely experienced this. Think about that ear-splitting screech you get when a microphone gets too close to a speaker. That's a positive feedback loop in action. A little bit of sound goes into the mic, it gets amplified, comes out the speaker louder. And that louder sound goes right back into the mic to get amplified again, and again, and again, until it's just this overwhelming shriek. So the theory here is that this exact same dynamic is playing out inside our bodies. These aren't just any old feedback loops. They're destructive runaway processes. The author has the perfect name for them: vicious cycles. Let's look at a couple of case files. First up, atherosclerosis. This is the whole process of plaque building up in our arteries, the thing that ultimately leads to heart attacks and strokes. So how does this cycle get started? Well, it all kicks off when some of that LDL, the so-called bad cholesterol, gets damaged or oxidized. This oxidized LDL sends out a distress signal, calling in the body's cleanup crew, immune cells called macrophages. But here's the fatal twist. When a macrophage eats that damaged cholesterol, it lets out this huge burst of highly reactive chemicals called reactive oxygen species, or ROS. And guess what ROS are really, really good at? Damaging more cholesterol, which of course calls in more macrophages, which release more ROS. You see the loop. It's feeding itself. And this is the really dangerous part. As the author points out, once this loop gets going, it doesn't even need the original trigger anymore. It's running on its own fuel now. It becomes, literally, a self-sustaining fire inside the walls of your arteries. The end result of this runaway cycle is the relentless, unstoppable growth of arterial plaque. It just keeps getting bigger and more unstable until one day it either blocks the artery completely or it ruptures and causes a catastrophic heart attack.
Okay, now let's take that same idea and move from our arteries into the brain, because the paper argues that Alzheimer's is driven by a very similar kind of vicious self-amplifying chain reaction.
With Alzheimer's, the villain is a protein called amyloid beta. A few of these proteins can misfold and stick together, creating a tiny seed. Then other healthy amyloid beta proteins start sticking to that seed, making it longer and more toxic. But here is the absolute gas on the fire. The surfaces of these growing chains are the perfect place for new seeds to form, and at a much faster rate. It's a process called secondary nucleation, and it turns a tiny problem into an exponential explosion of toxic protein gunk.
And this disaster doesn't just stay in one spot. These toxic clumps can actually travel from one neuron to the next, spreading the disease through the brain's own wiring, like a slow-motion fire consuming a forest.
So this all sounds pretty bleak, right? If these diseases are powerful, self-sustaining cycles, how in the world are we supposed to stop them? Well, this model actually points to a completely different and maybe more hopeful strategy.
See, the old way of thinking was we have to find the spark that started the fire. For heart disease, that meant going after high cholesterol. But the vicious cycle theory says, once the fire is raging, the spark doesn't matter as much. The new approach is to stop trying to find the first domino, and instead just pull one out of the line. You don't have to fix the whole system. You just have to break the loop. anywhere you can.
So what does that actually look like? Well, for atherosclerosis, maybe you develop drugs that act like sponges, just soaking up all those nasty reactive oxygen species. Or maybe you create a molecule that stops macrophages from being able to eat the oxidized LDL. For Alzheimer's, you could focus on designing drugs that cap the ends of those growing amyloid chains so nothing else can stick to them. Or even better, you could try to block that secondary nucleation step to stop new seeds from ever getting a chance to form.
And let's be really clear about the goal here. The idea isn't necessarily to reverse decades of damage. The goal is to hit the emergency brake, to stop the runaway train in its tracks. You want to halt that exponential progression and turn what was a fatal disease into something chronic and manageable. And obviously, this means that the earlier you can intervene, the better. So when you zoom out, this theory is bigger than just one or two diseases. It really offers a whole new lens for looking at the process of aging itself.
It suggests that maybe there isn't one single process of aging. Maybe what we call aging is actually the combined effect of dozens of these different vicious cycles, all running in parallel throughout our bodies. One in our arteries, one in our brains, another in our joints, another in our pancreas.
The author sums it up just perfectly. He says, aging can be viewed as the host of interconnected, exponentially progressing pathological processes mediated by positive feedback loops. It's not one thing, it's a whole host of runaway systems.
And this is a really, really hopeful idea, because it means we can stop searching for a single magical cure for aging. We don't need a silver bullet. What we need is a toolkit with specific tools designed to break each specific vicious cycle.
And that leaves us with one last huge question to chew on. If this model can explain the deadliest diseases of aging, what else could it explain? Could things we consider more benign, like wrinkles or gray hair, also be driven by their own little vicious cycles? What about something like chronic inflammation, which more and more scientists believe is at the core of aging? Could that also just be another runaway feedback loop, waiting for us to figure out which wire to cut?